So formal charges allow us to figure out which is going to be the best structure for a chemical compound. And by best, I mean the one that's most likely to exist in the real world. So let's start with a simple one. Let's look at CH4, methane. To calculate formal charges, we do that for each atom. So let's take a look at the carbon first. Carbon on the periodic table is in group 4 or 14, 4 valence electrons, minus non-bonding. These are the ones that aren't formed in chemical bonds. All of these electrons for carbon, they're bonded, so we don't have any non-bonding. And then bonding electrons, we have all of these right here. So we have a total of 8 bonding valence electrons. Divide that by 2. 4 minus 0 minus 4 is 0. So we can write the formal charge for carbon and put it right here in the middle as 0. So now let's try the formal charge for hydrogen. Since all the hydrogens are the same, they're symmetrical, we only need to do one. So valence electrons, hydrogen's in group 1, so 1 valence electron. Non-bonding, these guys are all bonded, so 0. And then the 2 bonding valence electrons divided by 2. 1 minus 1 equals 0. So the formal charge for hydrogen is 0, and that's the same for all the hydrogens since it's symmetrical. So that's methane. So we've calculated the formal charges for methane. Not too bad if you can remember the formula. So often you'll have more than one possible Lewis structure, and this happens quite frequently when you have something like sulfur in period 3, row 3 of the periodic table, or phosphorus in the same period. They can have more than 8 valence electrons, and that opens up some possibilities. So you want to check the formal charges, especially when you see sulfur or phosphorus. So let's try it. We'll do this oxygen first, and oxygen is in group 6, so it has 6 valence electrons. Non-bonding, that's these ones on the outside, has 6 of those. And then bonding, we have a bond right there, 2 divided by 2, so 6 minus 1 is minus 1. The formal charge on that oxygen is minus 1. For the sulfur, right here, we have group 6, non-bonding, that's these here, and then bonding, these and these are forming bonds, so we have 6 over 2, and 6 minus 2 minus 3 equals a positive 1. So this is going to have a formal charge of plus 1. For the last oxygen, we have 6 valence electrons, non-bonding, these here and here, so 4. And then bonding, 4 of those, divided by 2. 6 minus 4 minus 2 is 0. That has a formal charge of 0. Let's try this molecule over here. So we're going to do this oxygen. We have 6 minus 4, and then these are our bonding, so 4 over 2. That equals 0. Formal charge of 0. For the sulfur, we have 6 minus non-bonding minus the bonding, so we have 8 over 2 there, and that equals 6 minus 2 minus 4. We have 0 again, formal charge of 0. Finally, the last oxygen here, we have 6 minus 4 non-bonding. We have 4 bonding over 2, 6 minus 4 minus 2, a 0 again. Formal charge of 0. So when we look at these structures, we want to choose the one that has the formal charges close to 0. And in this case, that's right here. This is the structure that has the formal charges closest to 0, and therefore that's going to make it the most appropriate or the best Lewis structure, the one that we're likely to find in the real world. You've got your equation for figuring out formal charges. You can calculate them for each atom and then compare different structures. It's a little bit confusing at first, but with practice, it gets pretty easy. This is Dr. B, and thanks for watching.